fourth graders. This is week 9, lesson 1. This math lesson is for schools who are using the Bridges in Mathematics program. Today, we will be reading, writing, and representing decimals. Are you ready to do some math learning? Let's get started. Today, we will develop an understanding of the relationship between fractions and decimals using visuals and number lines in order to solve real-world problems. You have already learned a lot about fractions, and you've learned about decimals too. Today, we are going to focus on how they are related. We will be using visuals, such as a decimal grid, and number lines, such as this one showing hundredths, in our lesson today. Think about it, today's number. Examine the number in the picture on your screen. How many ways can you show 4/10? Write a story problem to go with one of your ways to show 4/10. There are many ways to show 4/10. You could show 4/10 by writing it as a decimal in tenths, like the picture shows. You could also write 4/10 as an equivalent decimal, such as 40 hundredths or even 400 thousandths. You can write 4/10 as a fraction or represent 4/10 on a decimal grid by shading in 4 out of 10 equal parts. You could also show 4/10 on a number line or represent 4/10 by showing 4 dimes. You could have written many story problems to go with one of your ways to show 4/10. For example, if you represented 4/10 as a fraction, your story problem could be, Emily and Natalie are working on a puzzle. Emily finished 1/10 of the puzzle. Natalie finished 3/10 of the puzzle. How much of the puzzle did they finish altogether? In that story problem, 4/10 is the answer. Learn about it. Let's learn about decimals. You have already learned some things about decimals during Unit 3 of Bridges. Let's review the definition of a decimal. A decimal is a number that relates to a power of 10. Decimals are another way to write fractions with denominators that are powers of 10, such as 10 and 100. We express decimals using digits and a decimal point. Here are some examples of decimals. We have 34 hundredths, 1 and 6 hundredths, and 12 and 835 thousandths. Notice that decimals can have one or more digits on either side of the decimal point. In 4th grade, we learn about tenths and hundredths. Let's review decimal place values. We can use place value grids to represent decimals. We use place value grids differently for decimals than we do for whole numbers. When working with decimals, the flat represents the ones place. The place value to the right of the ones place is 1/10 the value of the ones place. 10 of these rods make up one whole. Therefore, each rod is worth 1/10. This is the tenths place. The place value to the right of the tenths place is 1/10 the value of the tenths place. 10 of these units make up 1/10, and 100 of these units make up one whole. This is the hundredths place. There are more place values that are even smaller than hundredths, thousandths, 10,000ths, and more, but we will focus on tenths and hundredths today. We can represent decimals in many ways. We can represent tenths by using a tenths grid, by writing the number as a fraction with 10 as the denominator, and by writing the decimal in base 10 numerals using place value. Let's read, write, and represent this decimal. I can see from the grid that 2 out of 10 tenths are shaded. Therefore, we can write this number as a fraction as 2/10. This should look familiar. Because the denominator of the fraction is a power of 10, we can write it as a decimal as well. We have 2/10, so we will write the digit 2 in the tenths place. Because we don't have any entire grids shaded in, we don't have any wholes or ones. We will write a 0 in the ones place. When we read decimals, we first read the whole number, then say and at the decimal point, then read the digits after the decimal point as a number, and then say the place value of the digit that is farthest to the right. We can read this decimal as 0 and 2/10. When the whole number is 0, we can also just read the decimal as 2/10. We can also represent hundredths. We can use a hundredths grid, write the number as a fraction with 100 as the denominator, and write the decimal in base 10 numerals using place value. This is a hundredths grid. There are 100 hundredths in a whole. Let's look at this decimal. We can see that 1/10 is shaded in, and then 3 extra hundredths are shaded in. Let's write the decimal. There are still no entire grids shaded, so we will write a 0 in the ones place. There's 1 entire tenth shaded, so we will write a 1 in the tenths place. There are also 3 extra hundredths shaded, so we will write a 3 in the hundredths place. Our decimal can be read as 0 and 13 hundredths, or simply 13 hundredths. We can also write this as a fraction, 13 hundredths. Next, let's take a look at this decimal. We can see that only 4 of the hundredths are shaded in. As a fraction, this number can be written as 4 hundredths. Now, let's write this number as a decimal. Again, we have no entire grids shaded, so we will write a 0 in the ones place. There are also no entire tenths shaded, so we will write a 0 in the tenths place. Finally, there are 4 hundredths shaded, so we will write a 4 in the hundredths place. This decimal can be read as 0 and 4 hundredths, or simply 4 hundredths. Note that it is not written as 0.4. That decimal is read as 4 tenths. In order to write 4 hundredths accurately, we must write the digit 0 in the tenths place to show that we have no tenths shaded in. We also couldn't shade in this decimal 4 hundredths on a tenths grid because we would need to shade in less than 1 whole tenth. We can use a hundredths grid to represent both tenths and hundredths. Let's examine this decimal. We can see that 1 out of 10 tenths are shaded, so we can write this as the fraction 1/10. As a decimal, we must write a 0 in the ones place and a 1 in the tenths place to show 1/10. We can also write this number in hundredths. You can see from the grid that there are 10 hundredths shaded in. We will still write a 0 in the ones place and a 1 in the tenths place. Because there are no extra hundredths shaded in besides the ones that we already accounted for in the tenths place, we will write a 0 in the hundredths place. These fractions and decimals are all equivalent because they represent the same amount that is shaded. 1/10 is equal to 10 hundredths, which is equal to 1/10, which is equal to 10 hundredths. We can also use decimal grids to represent decimals greater than 1. Let's examine this decimal. Because we have 1 whole grid shaded in, we can write a 1 in the ones place. Then there are 4 extra tenths shaded in the second grid, so we will write a 4 in the tenths place. When writing this number as a fraction, we will need to write a mixed number since our fraction is greater than 1. We have 1 whole and 4 extra tenths. The mixed number is 1 and 4 tenths. We could have also written the improper fraction 14 tenths since there are 14 tenths shaded in. We can also write this decimal in terms of hundredths. Again, because we have 1 whole grid shaded in, we can write a 1 in the ones place. There are 4 extra tenths shaded in the second grid, so we can write a 4 in the tenths place. Because there are no extra hundredths shaded in, we can write a 0 in the hundredths place. Our decimal is 1 and 40 hundredths. We can also write a mixed number in terms of hundredths. Again, we have 1 whole and 40 extra hundredths. We can also write this again as an improper fraction. There are 100 hundredths shaded in the first grid and 40 hundredths shaded in the second grid. The improper fraction is 140 hundredths. These fractions and decimals are also equivalent because they represent the same amount that is shaded in. 1 and 4 tenths is equal to 1 and 40 hundredths, which is equal to 1 and 4 tenths, which is equal to 1 and 40 hundredths. We can also use number lines to represent decimals. This number line shows the length from 0 to 1 and is divided into 10 equal parts. Therefore, we can label each part as a fraction out of 10. We can label the number line as 1/10, 2/10, 3/10, and so on, all the way to 9/10 and then 10/10, which equals 1. We can also write each fraction as a decimal. We can label the number line as 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. We can see from the number line that the fraction 2/10 is equivalent to the decimal 2/10. They represent the same location on the number line. If we further divide each tenth into 10 equal parts, then we can show hundredths on the number line. There are 100 hundredths between 0 and 1 on this number line, and 10 hundredths in between each tenth. We label the tenths as fractions on the number line, but we can also label these same locations as hundredths. And just as we labeled the same points on the number line as decimal tenths, we can also represent those same locations as decimal hundredths. Each of our identified locations on the number line can be written in 4 ways, both as a decimal and as a fraction, as tenths and as hundredths. From this number line, we can see that 6/10 equals 60 hundredths equals 6/10 equals 60 hundredths. They all represent the same location on the number line. Let's identify marked points on the number line. What is this point on the number line as a fraction and as a decimal? If we count tenths starting from 0, we will count 1/10, 2/10, 3/10, and then 4/10. This point can be written as 4/10 as a fraction. We can also write 4/10 as a decimal. All tenths can also be written as hundredths. Therefore, we can also count each hundredth. If we count hundredths starting from 0, we will count 10 hundredths, 20 hundredths, 30 hundredths, and then 40 hundredths. This point can be written as 40 hundredths as a fraction. We can also write 40 hundredths as a decimal. You can write this point on the number line in 4 ways. Let's label one more point on the number line. What is this point on the number line as a fraction and as a decimal? This point is between tenths, so we can't represent it using tenths. Let's count by hundredths. We can count 10 hundredths, 20 hundredths, and now let's count by individual hundredths. 21 hundredths, 22 hundredths, 23 hundredths, 24 hundredths, 25 hundredths. This point represents 25 hundredths. We can also write this location as the decimal, 25 hundredths. Let's use our knowledge of equivalent decimals and fractions to solve this problem. Choose the numbers equivalent to 5/10. Note that there are not 2 decimals in this prompt. The second point is simply the period at the end of the sentence. Let's look at each number and determine if it's equivalent to 5/10. 5 is not equivalent to 5/10. 5 is 5 ones, not 5/10. Let's look at the next one. 5/10 is written as a fraction. It is the same as 5/10. That is the fractional way to represent 5/10. Next, we have 50. 50 is not equivalent to 5/10. 50 is 5/10, not 5/10. Let's look at 50 hundredths. Every 10 hundredths is equivalent to 1/10. So 50 hundredths is equivalent to 5/10. 5 hundredths is next. 5 hundredths is not equivalent to 5/10 because hundredths are 10 times as small as tenths. This would be at a different location than 5/10 on the number line. Next, we have 5 hundredths written as a fraction. Again, 5 hundredths is not equivalent to 5/10. Finally, we have 50 hundredths written as a decimal. Since the fractional form for 50 hundredths is equivalent to 5/10, the decimal form is as well. This decimal also shows a 5 in the tenths place and zeros in all other places. So the numbers that are equivalent to 5/10 are 5/10 written as a fraction, 50 hundredths written as a fraction, and 50 hundredths written as a decimal. Try it. Now it's your turn to practice reading, writing, and representing decimals. Log on to Schoology to complete the Try It assignment that your teacher pushed out on decimal fractions and numbers. Then, show what you know about decimal fractions and number lines by logging onto Schoology and completing your Show What You Know assignment that your teacher pushed out as an assessment. Make sure to submit this to your teacher. Well, 4th graders, it's been a blast hanging out and relating fractions and decimals with you. Until next time, have a great day.